Hello out there, welcome again to this tutorial on mensuration. Still looking at arc, sector and segment of circles. In this video we'll be looking at miscellaneous problems. So in the previous videos we've discussed on the length of an arc, perimeter of sector, area of sector and area of segments of circles. Check the description section of this video and our YouTube channel to get the links to our previous videos on this topic, also the subsequent videos. So we take our first miscellaneous problem. Problem 1. The angle of a sector of a circle is 210 degrees if the perimeter of the sector is 45(1/3 centimeters. What is the area of the sector? We take pi to be 22/7. In this problem, we are not given the radius of the sector, even though we are given the angle of the sector. So we won't be able to calculate the area directly. So we are going to use the perimeter of the sector given and the angle of the sector to calculate the radius of the sector. So we state the formula for the perimeter of the sector as 2r plus theta over 360 times 2 pi r. So what we do here is we know the perimeter, we don't know the radius, we need the angle. So we substitute those parameters to enable us calculate the value of r. So we have the perimeter as 45 whole number 1/3. Changing it to improper fraction, we have it as 136/3. That is the perimeter is equal to 2r plus 210/360 times 2 times 22/7 times r, since we don't know r. So this still maintained. This is a 2r. Simplifying 210/360 times 2 times 22/7. If you press our calculator, it gives 11/3. So multiply by r gives 11/3r. So we go ahead to make this one a single fraction. So the LCM there is 3. So 3 times 2r gives 6r plus 11r. So 3 divided by 3 gives 1 times 11r gives 11r. So that will give us 17r/3. So simplifying this, we have a 17r/3. So since the denominators are equal, therefore the numerators are equal. So we now have 17r is equal to 136. 136 divided by 17. Because to get the value of r here, we divide both sides by 17. We'll be left with r here. 136 divided by 17 gives 8 centimeters, which gives the radius of the sector of the circle. Now we go ahead to calculate the area of the sector. To calculate the area of the sector, we know our formula as theta over 360 pi r squared. So we have area equal to 210/360 times 22/7, and our radius is 8, so times 8 squared. So pressing our calculator, we have 117.33333, which is 117.33 centimeters squared, giving our answer to 5 significant figures or 2 decimal places, since we are not given any degree of accuracy. So this has done justice to problem 1. So we go ahead to problem 2. For problem 2, a circle of diameter 21 centimeters is divided into 3 sectors, such that one part is 30% of the whole, while the remaining sector is divided in the ratio 1 whole number 4 over 7 ratio 2 whole number 3 over 7. What is the area of the largest sector? We take pi to be 3.142. Let's get the angles of the sectors. So we say, let the angles of the sectors be A, B, and C. And we take A to be the one with 30 degrees of the whole sector. So to calculate angle A, since the angle of a whole sector is 360 degrees, so to calculate the angle of A, we find the 30% of 360. That gives 30 over 100 times 360 degrees. 2 zeros will remove this. 36 times 3 will give 108 degrees. So that is the angle of A. And the angle of B and C now, that is angle B plus C, will be 360 minus 108 degrees. That gives 252 degrees. We now divide these 256 degrees in this given ratio. So we express the ratio as B ratio C to be equal to, so express this as improper fraction. 7 times 1 gives 7 plus 4 gives 11 over 7. Then the 7 times 2 gives 14 plus 3 17 over 7. So we have it as ratio 17 over 7. Since the denominators are equal, so we can simplify the ratio as whole number to become 11 ratio 17. The larger angle here will be the angle with 17. So we say angle C is 17 over 28. Where is the 28 coming from? 11 plus 17, then multiply by 252 degrees, and that will give us 153 degrees. If you press your calculator, we can then calculate angle B to be 252 minus 153, which gives 99 degrees. So if you look at the three sectors now, this A has 108 degrees, C has 153 degrees, and B has 99 degrees. So the largest sector now is the one with the largest angle, which is sector C. So we say the area of the largest sector now, which is what is required in problem 2, is theta over 360. That's 153 over 360 times pi, which is 3.142, then times r squared. Our r here will be 21 over 2. So that will give us times 21 over 2 times 21 over 2. So simplifying this from our calculator, we have our answer as 147.26 squared centimeters, which gives the final solution to problem 2. And we move again to problem 3. For problem 3, calculate the area of the shaded part in each of the diagrams below. For diagram A, as usual, to calculate the area of the shaded part, we calculate the area of the sector minus the area of the triangle. So to calculate the area of the sector, we still remember theta over 360 pi r squared. So we have it as 105 over 360 times pi. Oh, we are not given pi. We still use 22 over 7, then times 10 times 10. That is theta over 360 pi r squared. Then minus half r squared sine 105 degrees. So this is multiplied by sine 105 degrees. For the first part, before the minus sign, we press our calculator. We have 91.667, then minus 50 times sine 105 degrees. From our calculator, we have it as 0.9659, and simplifying this, multiplying 50 by 0.9659, we have it as 48.295. And now finally, subtracting this, we have 43.372 squared centimeters, which gives the area of the shaded part in diagram A. Then we go to the second diagram. The area of the shaded part there is, this is a rhombus and a sector of a circle here. So the area of rhombus minus the area of the sector will give us the area of the shaded part. So we have it as area of rhombus minus area of sector. So from here, the area of rhombus, if we divide the rhombus into two, we have two similar triangles. That is where this line is the line of symmetry. Now we can find the area of this and multiply by 2 to get the area of the entire rhombus. So to calculate the area of this is half 12 squared sine 95 degrees. Multiplying it by 2, the half will go. So we'll just have it as 12 times 12 sine 95 degrees. Then minus area of sector, 95 over 360 times 22 over 7 times 12 over 1 times 12 over 1. This is theta over 360 pi r squared. So where the side of the rhombus is our radius of the sector of the circle represented in the diagram. So simplifying this, this is 144 sine 95 degrees is 0.9962 minus 95 over 360 times 22 divided by 7 times 144 gives 119.43. 144 times 0.9962 gives 143.45 minus 119.43. So finally we have 24.02 squared centimeters, which gives the solution to problem 3b. And that is the end of solution to problem 3. We go to problem 4. For problem 4, calculate the area of the shaded part in the diagram below. Here we seems to have what we do now is we can separate the two circles and the sector. If you draw a line like this, separating it, move this to the right, and since that one has gone, we'll be left with this. So we'll move this to the left. So this has been separated into the individual circle and the sector plus the shaded part, which is the segment. Wow. So since they are equal, we just need to calculate area of 1. So then multiply by 2. So this angle here is 100 degrees, because 260 plus 100 now will give us 360. Yeah. Now to calculate the area of the segment, which is the shaded part, we find the area of the sector minus the area of the triangle. So area of the segment is area of sector, that's 100 over 360 times 22 over 7 times 7 times 7, then minus half times 7 times 7 sine 100 degrees. So before the subtraction, we simplify. From our calculator, we have it as 42.7778 minus 24.5 times 0.9848, that is sine 100 degrees, is 0.9848. Multiplying 24.5 by 0.9848 will have 24.1276. Subtracting this, we have 18.6502 squared centimeters. That is the area of the shaded segment here, and the same thing, the area of the shaded segment here. To get the area of this shaded part in the original diagram, we just multiply the area of the shaded segment by 2. So area of the shaded part now is 18.6502 multiplied by 2, and that gives 37.3004 squared centimeters, which gives the area of the shaded part in this diagram. And that is the end of solution to problem 4. We go to problem 5. For problem 5, calculate the area of the segment of a circle below, given that PQ is a chord of size 18, PQ is a chord, M is the midpoint of PQ, okay, 18 divided by 2, 9 here, 9 here. AM, that is AM is 3 centimeters. Angle AMP is 90 degrees. So we have to take pi to be 22/7. Wow. What we do now is we need to complete the sector. Since this is the segment of a circle, we complete the sector. This is center O, and the radius is R here. So calculate the area of the sector, calculate the area of triangle, subtract from, we'll get the area of the segment. So before we go, we need to find the value of R, which is the radius of the sector of the circle. Now we look at this OA is a radius, and OM will be radius minus 3. Yeah, that's R minus 3. We now consider this triangle MOQ, where we have this is right angle. Yeah, this is the hypotenuse. This is the other two sides. Yeah, we can apply Pythagoras theorem. So by Pythagoras theorem, we have the hypotenuse, which is r squared, is equal to 9 squared plus r minus 3 squared. So we have r squared, 9 squared is 81. Expanding this, we have r squared. Squared is, the method of expanding this is very simple. Let me give you the shortcut. Square r, which is r squared. R times negative 3 gives negative 3r, multiply it by 2 will give us negative 6r. That's the method. Then we now squared negative 3, which gives 9. If you have a problem like this, square of difference of numbers, or it could be square of sum of numbers, what you do is this method of expanding, you are there. So if we collect the like terms now, this is r squared coming to meet this r squared will be 0. So negative 6r coming to this side, we have it as 6r. Then 81 plus 9 gives 90. Dividing both sides by 6. 6r divided by 6 gives r. 90 divided by 6 gives 15. So the radius is 15 centimeters. From here now, we need to calculate the angle of the sector again. So if you take the angle of this triangle to be alpha degrees, so what we do is opposite and hypotenuse, that's trigonometric ratios. The ratio connecting opposite and hypotenuse is sine, so we have it as sine alpha is equal to opposite 9 over hypotenuse, that's radius, which is 15. That's over 15 gives 0.6, and alpha is sine inverse of 0.6, which gives 36.87 degrees. And from here we can calculate the angle of the sector, The angle of the sector now is times 2 of alpha. So we say theta is 36.87 times 2, which gives 73.74 degrees. We can now go ahead to calculate the area of the segment. So the segment here, area of the segment now will be area of the sector, the entire sector minus area of the triangle. And area of the sector is theta over 360, that's 73.74 over 360 times 22 over 7, that's pi, times r squared, that's 15 times 15, then minus half 15 times 15 sine 73.74 degrees. So from here we have, from our calculator before this, 73.74 over 360 times 22 over 7 times 15 times 15 gives 144.85. Then this is going to give us everything also from the calculator gives 108.00, and subtracting we have 36.85 squared centimeters. And that is the end of solution to problem 5, having calculated the area of the segment to be 36.85. And this is the end of this tutorial. Thank you for watching. Like and share this video. Remember to subscribe to our YouTube channel. Check the description section of this video on our YouTube channel to get links to our previous videos and subsequent videos on this topic. Until we come your way again, goodbye.